Okay, we need to make sure that we're comfortable adding and subtracting fractions in general before we start moving into our rational expressions, which tend to have variables and things involved. So here we go. When we're adding and subtracting, this is where you do need to have those common denominators. And it's for this very simple reason. If you're comparing parts of a whole, well, then you need to make sure that the parts you're comparing are the same size. So you've seen this before, right? If you got two wholes and this one you divide into half and this one you divide into quarters, well, you're not comparing pieces that are the same size. So what we do is we find a way to make them be the same size. And in this case, the way you do that is you cut your halves in half again. Now all the pieces we're dealing with are the same size. That's what getting a common denominator does. We're going to be searching for the LCD, the least common denominator. It will be the smallest number that is divisible by the original denominators. Why do you want that? To keep your numbers small. That's why. All right, let's give this a quick review here. So between 8 and 12, right now, these denominators are different. We want them to be the same. So we're looking for the smallest number that I can divide by 8 and by 12. The LCD will always be as big or bigger than the numbers you started with. So it's going to be at least 12. And since 8 doesn't divide into 12, it's going to have to be even bigger than that. Here's my suggestion when you're dealing with numbers, is take the bigger number and look at its multiples until you find one that divides evenly by the other number. So does 12 divide by 8? No. Does 24 divide by 8? Yes. To turn an 8 into a 24, you got to multiply by 3. So do that down below, do that up above. 9 over 24 is the same fraction as 3 over 8. Then let's take a look here. To turn a 12 into a 24, you multiply by 2. So do that down below. Do the same thing up above. You end up with a 14 on the top. Oops, and you see what I did? I wrote a 12 down there. And I, of course, meant to write a 24. The whole point was to get the denominators to match. Now that the denominators are the same, leave it the same. That's just telling us the size of piece that we're dealing with. It's 1/24th of a whole. The top is telling us how many of those 24ths we have. Add them up. 9 plus 14 is 23 24ths overall. Okay, that shouldn't be new. I hope it looks somewhat familiar. So do this one. Between 13 and 1, these tend to be the easiest type to do because your least common denominator is just going to be 13 because any number is divisible by 1. So the first fraction doesn't need to change at all. The second one does. If you multiply by 13 down below, you need to do the same thing up above. That's going to give us a 26 up top. 9 minus 26 is going to be negative 17 thirteenths. And so what we see is that in order to do your additions and subtractions, denominators must match. Let's do one here. I hope this kind of matches up with some of our radian training from the trigonometry units. Looking at 6 and 10, we want to find the smallest number that divides evenly by 6 and 10. So let's just look at multiples of 10. 10 doesn't divide by 6, 20 doesn't divide by 6, 30 does. Okay, so our least common denominator is going to be 30. To turn a 6 into a 30, you multiply by 5, top and bottom. To turn a 10 into a 30, you multiply by 3, top and bottom. Right? Okay, 5 pi minus 3 pi, that's 2 pi, with a 30 on the bottom. Ooh, and this one then reduces in the end. That happens sometimes. Divide by 2 on the top and divide by 2 on the bottom. And then lastly, if you haven't already done this one, would you give this one a shot? This time, our least common denominator is going to end up being 20, because if you look at multiples of 5, 5, 10, 15, 20, the first one that divides by 4, that's 20. So to turn a 5 into a 20, you multiply by 4. So we'll do the same thing top and bottom. Oh gosh, and 13 times 4 is 52. And then over here, to turn a 4 into a 20, you multiply by 5. So the same thing top and bottom. We'll have a 35 on top. 52 plus 35 is 87 over 20. What I need you to take away from here, before you do any adding and subtracting, you do need to get that common denominator. That needs to be there first. We're going to now do that same thing with variables and stuff. The process is the same. Get your denominators, multiply above and below to make a match, and then put the numerators together.